White King. Yeah, so much for child protective caps. That doesn't do jack shit. Yeah, I can see a lot of kids in Australia drinking this shit. No matter how tight I get this, the prick just comes straight back off. Hello and welcome to another exciting episode of the Astro 30's Electronics Lab with me, your host, the Astro 30. Now I'm starting to sound like Cool Dude Clem. Anyhow, today I've got another kit here to build. This kit is called the Super Ear. And the little description here says there are zillions of sounds out there if only you could hear them. Like, for example, a farting snail. No, this project lets you hear more than you could with your normal unaided ear, particularly high frequencies, which are often the quietest, make conversations clearer and experience a whole new world of unexplored sound. Make conversations clearer. Yeah, that's a good way to put let's listen into other people's private conversations, like your wife on the phone in the next room. Or basically, you could use it as a hearing aid if you want to really want to go that far. But it does say down here, this is not a hearing aid replacement. Processed panels. Now that means it does provide a case to put everything in, but there's no drilling required. Kit includes case, processed panels as I just previously mentioned, revised PCB, 9-volt battery and components. The kit requires headphones and some glue. So let's open the packaging and we'll see what we've got here. So off with that. Here's the instructions all mangled in with everything else. Bag of components. It's got two 3.5mm sockets there. And there's the PCB down there. Fairly small. That's one of the panels to the case. And the other one behind it. Here's a battery, well protected. Don't know if that's any good. Oh yeah, I just stuck it on my tongue. It seems okay for now. Here's part of, well, the two halves of the case, and its mounting hardware like the screws. And the instructions. And here's the schematic, and as I suspected, it uses the horrible LM386 IC to power the headphones. I would have loved to have seen a different choice of IC or even a discrete amplifier stage here and make it more interesting, not just your crappy LM386, but yeah, it is what it is. Now at the input stage here, this is the first amplifying transistor, Q1, which is a BC548, and it uses a Electret condenser microphone as the sound pickup. You've also got a socket here for an extension microphone, so you can have like a boom or something connected to it. And that's forward biased by this resistor R1, because these Electret microphones require a small voltage on them to make them work. And then the DC that's going to now be present on this microphone input is filtered out by this 2.2 microfarad bipolar capacitor, which is fed into the base of Q1, which is just a standard amplifier. There's nothing really special about it. The output is taken from the collector, going through this electrolytic 2.2 microfarad capacitor, which is going through this 100k resistor. It's got a tone switch here, which is switching between C3 and C4 and nothing. So I'm assuming high frequency and low frequency, even though that these capacitor values aren't marked. So this 100k and these two capacitors will be forming a filter. That then goes into this logarithmic 10k volume pot, which is then fed via this 47k resistor into pin 3 of the LM386, and it looks like they're not using the 20 decibel gain boost where you connect between pin 5 and pin 1 a capacitor and resistor to give the output gain of 200, so they're using it at the standard 20. So that goes through the Zobel network here at the output, just to stop this thing from going into self-oscillation, which they're very good at doing on their own. Going through this 47 microfarad normal electrolytic capacitor, a 10 ohm resistor here, out through to the headphone socket. I'm not sure what the function of the MOSFET is at this stage. Oh right, I just read the little description down here. What this MOSFET does is it actually connects power from the 9 volt battery, in this case the negative ground or negative rail, turns the circuit on when the headphones are plugged in via the switches in here. So it saves power when you unplug the headphones, which is kind of neat. So this is the capacitor values for C3 and C4 for the filter network to give a boost at certain different frequencies. So if you wanted to boost the 9 kilohertz range, the upper high frequencies at plus 3 decibels, you would use 180 picofarad there. 820 picofarad gives 3 decibels at 2 kilohertz, and then you get down to 1.5 nanofarad, which is not supplied with kit. So I'm assuming that all these values are supplied, bar that one. So you can actually choose 2 of these for either C3 or C4 up there. And on the next page it says, not a hearing aid. While the Super Ear is an interesting and fun project to use, it can also be used to assist those whose hearing is perhaps not as good as it used to be. It works well in this respect, but if you find that the Super Ear doesn't offer the level of assistance that you required, then we strongly suggest that you consult a qualified audiologist or medical practitioner. We do not intend that this device be used as an aid in case of serious hearing loss, but is may be able. But man, that is bad English. But is may be able to help those with a slight hearing problem. Yeah, whatever. Now anyway, they say the construction time on this is around about 2 hours, so we'll soon find out. It's fairly straightforward. Here's the diagram for the overlay for the parts. As I say, we have to fiddle with the values of C3 and C4 to get the filtering that you want using that table on the previous page. So it's really up to you what frequencies you want to boost. So on the last page there is a few things to concern ourselves with when we do the final construction. Process case shells with trimmed standoffs. Ensure the case halves are oriented correctly as they are polarized. The blank PCB and battery used to trim the case standoff. So one of these standoffs here has to be removed to allow the battery to fit in there properly. So to start construction we need to place the PCB that's unassembled into the lower half of the case shell. And this is the shell through which you fit the case screws. Secure the PCB to the shell with 3 screws. Next, fit the battery snap to the 9 volt battery, making sure the bare ends of the 2 leads do not touch. Trim the exposed standoff so that the battery and snap fit in tightly. So using the photos on the back page for reference, there's the normal blank panels that come with it. We don't need them. So there's the screws for the case itself. We don't need them right now. But we do need to fit this the correct way together. Now we can see there's a lip here and a lip here. Now these would locate into recesses on either side, so basically you have to get them so there's one lip on one side and one lip on the top half on the other side, so the case fits together nicely like that, because it won't fit together like that except at an angle. So that's the way that it's supposed to be oriented. So the board would live on either half, because there's standoffs on here and standoffs here, they want us to remove this fourth standoff so that the battery can sit in here, because at the moment it won't, because yeah. So next question is, how do we get that standoff off? Well, you could use a knife and spend all day doing it. I'll take a pair of side cutters and I will roughly cut off most of the standoff like that. Alright, so I was going to use a like a grinding wheel in this, but I'll just use the cut-off wheel. Try and not get the cord in the way. That's a lot better than it was when it started. Didn't do too much damage to anything. That's the beauty of working with ABS plastic, it's so easy. Okay, so battery in, this half of the case on. Oh yes, that fits a little bit nicer. Neater would be a better word. Yeah, I might need to take a little bit more off of the plastic work in the standoff to make that battery fit in there nice and easy, but for all intents and purposes it's quite good now, so I'll just continue. Try not to cut through the screw mounts. If you can, try and avoid that, that'd be great. Okay, that's about as much as I want to take that, because otherwise I'll be here all day just screwing around with that. So this has to be test fitted with this thing on here, preferably the right way around. Just make sure that it's not interfering with the case, which it should not be. Just want to make sure everything fits. It does, but the battery's still going to want to go sideways, so I've really got not much choice there, but hopefully it'll all work out in the wash. Anyway, moving on, we can now start construction. Ooh, take that off. We can now start construction of the PCB now that the case has been prepped. So that's the next thing I'm going to do. Okay, now this circuit board is too small to fit into the tool that I normally use. So I'm just going to use this clamp. I've removed the magnifying glass part out of the way, just mainly so that you can see it. Now, I'm going to start with the resistors, and we have got what looks like 470k. There's one there. Help if I had a pair of pliers. So I'll install this first resistor. Actually, what I should do, and this is actually double-sided too by the looks of things, with plated through holes. Indeed it is. So did that work? No. Trying to get that flush. There we go. Now it's flush. So I'll solder this first resistor in, and being double-sided, it's going to take a little bit more dwell time for it to transfer from one side to the other, like about that. And then we trim off our excess. I know I'm only doing one resistor, but yeah, and if you give it enough dwell time, it will come through to the other side, as you can see there. There is an IC socket here somewhere, which is not out in my bag of components yet because I didn't get it out. So that's going to be the next thing I'm going to install. You could solder directly to the IC if you wanted to, but they give me an IC socket, so I'm going to use it. That goes around that way. So in order to keep that where it is, this tool is so annoying. And one of the leads over. These are just standard IC sockets, they're not those match pin ones. Sorry, machine pin. I keep calling them match pin, I don't know why. It's machined pin. So I was propping it up with my finger, take one side, or one corner, then the other, and then I can finish off the rest of the IC pins. 2 odd seconds should be enough just to get it to permeate through both layers. And that's the IC socket in nice and straight. So now we can move on to the rest of the resistors. And as I've said previously, if you have trouble reading resistor values, for example, this is a brown, black, black, gold, brown. You also have to know which way around to read it. Some of these 5 bands can be a prick. Use a multimeter. Now, brown, black, black, gold would be 10 ohm. Because gold is divided by 10, so on the multiplier. So normally if this was 100 ohm, it'd be a black, so that'd be 0 zeros for the multiplier, so it'd be 1 0 0 with no zeros, so that's 100. This is 1 with 0 0 divided by 10, so it becomes 10.0, so 10 ohm. So those can go in next, and then I'm just going to work my way through the rest of the resistors and we'll come back. Now, as usual, these circuit boards, PCBs from Jaycar, kit distributors, are very well made, I must admit. They're a lot better than the Chinese ones, and I reckon more likely there is a PCB manufacturing plant in New Zealand, and I reckon most of the Jaycar kits are made in New Zealand. Just saying. It probably would have been easier to solder that last one with the leads cut on the others, because they're just in the way. But anyhow, so I'll cut off the excess now and fix up any joints that look sus. Just fix up a few joints that look a bit bad. Right, so that's the resistors installed, and 2 of them went like proud of the board for some reason. Not sure exactly why that happened, but alright. I think that's going to be a bit better. Right. Now we can move on to something else, which is capacitors. I'm going to start with the lower profile capacitors, and we've got 180 picofarad here. Now these are for the feedbacks for the filter for C3 and C4. So wherever it says C3, C4, I'm going to leave. So I reckon all those ceramics are for that. We've got these monolithic 100 nanofarad ones, which I'm going to install next. I think there's only one actually. I reckon the other one's for C3 or C4. Looks like it. So I've only got one there. So next I might install this extension mic socket because it's convenient, and the headphone socket because it's also convenient. But however, I don't know if that's going to work with the case now, because is that going to come out the back? Try putting it the right way around. Oh, it should come out the panel, yeah. No, they are definitely ball mounted. I was just checking to make sure that you mount them on the board and don't like have fly wires connected to them or something. So I don't think it matters which socket goes where because they're both the same. They look relatively both the same to me. So these have to be in there as flush as possible so that when you line it up to the panel at the front, nothing's squiff. Otherwise you'll be there enlarging holes, which is something you probably don't want to spend all day doing. Okay, that's the sockets installed, so I might just take off the mounting screw nuts, what do you want to call them, place them in something else, because panels have got to go on that, so we don't need them on there at the moment. Now, next stage would be, well, I guess I could put the electrolytics in now. So I'll start with that, so 16 volt 10 microfarad. Make sure to get these around the correct way, positive's marked there, and the shortest lead on a capacitor is negative. That one there. I believe these can stand all the way up on the board without having to lay down. I don't think it's going to interfere with the top of the case. I can't see any reason why it would. So you could just actually, you know, make it easier on yourself and just do that. And then put it in where it goes. Right, so that goes there, next to the IC. I'm having fun doing that. So that goes there. Which goes... how much was this kit, by the way? It was $29.95 from Jaycar. The catalogue number will be in the description. Now, I don't know how many of these are available in Jaycar, how limited the supply is or not. So I will try and find a link to a supplier on eBay maybe, where you can get the kit from. What am I going to use this thing for? Buggered if I know. I just bought it because I thought it was a bit of fun. So trim off the excess leads here. Okay, so that's the capacitors installed by C3 and C4, because I haven't actually decided what I'm going to do there. Okay, I suppose I can mount the little BC548, this one here. Just double check that it is a 548, yes it is. Lose it. So that can be mounted in next, and then I'll think about mounting the MOSFET. I just have to double check the instructions for that. Make sure you don't have to like do something funky with it. I don't think so. Alright, so that's the transistor in. That can be soldered. Right, I just read the instructions about the MOSFET and it didn't say anything particularly about how it's mounted. They did say that there's two different types of footprint here for two different types of MOSFET, the KA-1809 version and the KA-1809 version. They've supplied the KA-1809. It's only drawing about 7 or 8 mA through the transistor, so either would do. So don't be surprised if you see a small TO92 version. In other words, you've got two transistor looking things. Double check what they are before soldering them in, if you've got two of them. In this case I don't, so that just goes there. And as far as what I was reading, it doesn't say anything about mounting it flat or anything, so it should work fine just like that. So what I'll do is I'll hold it while slipping buggering around with the soldering iron. Right, just to get one tacked in and then finish it off. And as it's only drawing 7 to 8 MA, it shouldn't require a heatsink either. Now, that's the MOSFET in, and it's close to the board as it can get. I'm missing another 100N, that's where that goes. Okay. I love building kits, I must admit. It's a good pastime. Okay, with the potentiometer, they want us to remove this little locating lug, which is at the bottom of the pot. And just like with the 16mm versions, the easiest way is just get a pair of pliers and sort of break it off like that. The only thing is this frickin' pole. So that gets soldered in to the circuit board. Okay, so that's soldered in. All that's left now is the electret microphone, which has to be mounted as flush to the panel as possible. So if we look at my enormous penis, I mean, we look at the panels here. This is the hole for the microphone. So that electret microphone, wherever the hell that's gone, which is here, has to sort of be as flush with this panel as possible. So my thought on this, I don't think these little dags here need to be here, by the way. They can be removed. That's just the perforations they use to join the parts together when cutting them out, see, because it won't fit with them on there, so you have to remove them. Pretty much like that. And I probably would go as far as just sanding the edge where the perforations were, just to make them a little bit smoother. Don't have to be too anal about it, just so as long as it's smooth. Okay, so what we want to do is, now I have no idea what it is I'm doing. So I'll get to the capacitors for the different frequencies in a minute. For now I just want to get the microphone to line up in the case where it needs to be. Put it the right way around. Okay, so we use the provided screws. There's 3 of them. When I can find a screwdriver, I'll put all of them in just so that, well, it might have been a good idea to have actually put the front panel in first so that it was actually on the end of that shaft, because it won't fit in there now with the circuit board screwed in. So that needs to go onto there. I'm not going to bother putting a nut on it. And in this case 2 screws will do for now. I don't need to put all 3 in. Just something to hold it. Alright, so microphone mounts there. So I want to get this the right way around the first time, so I've got to figure out where the positive is. It's not clearly marked. Okay, and even though it's not marked, I just read the instructions. You fit this to the PCB with the leads closest to the PCB so it matches the polarity. So that's exactly what I'm going to do. And if it doesn't work, well, we'll soon know why. But yeah, it would have been nice if this had, like, you know, the polarity marked on it. It wouldn't have been that much of a difficulty to do. So I'm just trying to work out where I need to bend my leads without getting cramps in my fingers. Okay, so about 5mm. So I'll bend him in about that. It should be about right. Now this is going to be interesting to get in there, so I need to take it back out of the case. I mean, really? Okay, let me put a locking nut on the mic connection. Just to hold that still. And then try that again. Right, well, you're a pain in the ass. And then, just to make sure that the leads are in the board properly, I'll put the whole concoction into the case. Put a screw or two into it, just to hold it. Make sure that's perfectly flat. Get that as straight as possible. And then, here's a little trick I learnt from my grandma. I'll solder the microphone from the top of the PCB. And that way I can get that as straight as possible. Which looks like about there. Okay. And by rights, the way I've bent that, I shouldn't really need to trim any leads off the other side. No, all I need to do is just fix up that joint there. Okay, so that's that in. Might as well leave that attached, don't need to take it off right now. The electret microphone's installed. So now I need to figure out what frequencies I really want to switch in there, if any. Okay, just for shits and giggles, I'm going to go for 180 picofarad for the 9 kilohertz plus 3 dB and a 4N7 for the 370 hertz. So the C3 and C4 respectively. There's the 4N7, which is a 472, so they're in. Now we can turn our attention to the switch. This switch is a 3-position single pole dual throw. So center is off. You got one way, off, one the other way. So this is mounted in the case, so it's actually screwed to the front panel, and what you need is tin copper. It sits like that on top of the board. What you need is tin copper wire to go through these little through holes here into the terminals of the switch. Now, they didn't supply, yes they did. They did supply us some tin copper wire, which is nice, so I'm going to use it. They want you to cut that into lengths of 2.5 centimeters roughly each. So that's about 6 centimeters, so that should be 5. So if I cut it like that and like that, that gives me 3 almost equal lengths. And what we do is we can solder them into the board first. However, which way you want to do it. Probably not like that. Make Actually, what might help is if I put the front panel on. To add as a bit of a buffer. Now, as awkward as I'm doing things, you could probably find an easier way of doing it. But for now, I'm just doing it so it solders in. They also say there might be a little bit of gap between the body of the potentiometer and the front panel, or rear panel, whichever one you want to call it. So you can actually use the provided, that's tight, provided washer, which is supposed to go on the outside to take up the gap, and you can actually bend it slightly at each corner just to prop it out. But I tend to think I don't really need that. I think it fits just perfectly as it is, or at least it should. So if I now bring the case in, bit of a tight fit, but yeah, there is a bit of a gap there, I can see it. Yeah, okay, so I am going to need that washer. So what I might do is, whilst I'm thinking of it, let's take the washer, put a slight bend either corner, enough. Put it with the bends facing towards the panel. And this might take a little bit of modification to get it right, but because that doesn't now fit in there properly. Yeah, so that might be a little bit tight. So I probably don't want such a bend on it that much. Bend it back a bit either side. Let's try that. It's only slightly bent. I mean, once you do the nut up, it's going to bend it anyway. Oh yeah, that fits much more nicely. Moving on to the switch. Now, they have a nut here to adjust the depth. So, I'm probably going to adjust it so that the depth is as minimal as possible. So I want it around about there somewhere. So I'll take that in. I'll use this shake-proof washer on the inside and just leave it with enough threads poking through on the outside to do it up. So, just tight as I want to get that. Oh, that was not what I intended to do. Right, so now all we need to do is get these wires through each of these eyelets. So I'm going to do a little bit of manual buggery. Try and actually pull them through until they're straight, because they don't necessarily need to be looped around the switch to be soldered. They just need to be in there and then pulled through so that they're actually straight with the board. There's probably an easier way of doing this, but I think this method works. It's a little bit more time consuming than necessary, but it works. So I get this last final one through, and that was the easiest one of the lot. So now I can solder the switch in, and that's that part of the construction complete. And now we need to deal with the 9-volt battery clip. I didn't use this extra washer for the switch, doesn't matter. So now I need to work out where that goes. That goes in there. So they do ask you to actually cut the leads down, 1 to 4 centimeter, 1 to 5 centimeter. Probably be just as easier to cut them to the same length. So take our battery, orient it how it's going to go in there, which is probably going to be that way around. Or can it go that way? Yeah, so what I might do is I'll cut them to the same length. And then we'll strip them back. Take that out. Now, ground goes there, and the 9-volt positive goes there. Alright, so bend that over that way, bend that one over that way. Solder them in. Not too long because you'll melt the insulation of the wire on the other side. Just long enough to get it in there. Trim off my excess lead. Get off of there. Put it back in the case for the final time. The right way around. Okay. Oh, that one just stripped out. Brilliant. Okay, well, I won't tighten them too much. It should be tight enough. Oh, it's held. Be careful with that, not to strip them out. Now, the good thing to do now would be to install the LM386. So I'll do that now. Not just that way. I've got replacements of these anyway, I think. So if I blow one up, it doesn't matter. I shouldn't blow it up as long as you put it the right way around. Alright, that's in there. Now, probably put the knob on. So that goes, well, that's a really tight fitting knob, isn't it? So I have other knobs that I've got lying around. I might try a different style of knob here just for shits and giggles. That one fits a bit tighter and it looks a lot nicer too. There we go. So I'll dispose of that. Now we're ready to test it, I guess. So I'll plug the battery in. Ah, for fuck's sake. Really? How did you do that? Fuck me. Right, so now what they want you to do is plug in the headphones, and about after a second or two you should be able to hear everything being picked up with the mic if the volume was up. So I'll turn that up a little. Tones in center so it's defeated. I heard a pop, and now I can actually hear myself. I can hear myself. And that boosts the high frequency. Oh my god, that sounds like shit. And that boosts to low frequencies, but I can't hear a difference. But that's with the volume full up. So if I put my oh. Right, so what I'm going to do is, you can't hear it, but I can. So I'll unplug that. I'll plug the headphone out into the line input of my interface, and I'll record an audio sample from it once I find a lead. Alright, this is what the sound quality is off of the unit here on the desk going into the interface. There is a bit of a buzz. That's not actually present with the headphones normally plugged in. But yeah, as we can hear, it's pretty loud. So if I switch this, if I put my finger on the lead, it grounds it properly and the noise goes away. How nice. So I'll keep my finger there. Let's go to high frequency. And you can hear that the hiss has really increased, and my voice sounds rather distorted, like it's a bit of a old, gramophone record or something. This is Thomas Edison. Mary had a little lamb. Its fleece was white as snow, and wherever Mary went, the lamb was sure to go. Yeah, sorry. Anyway, switch it back to increasing the bass frequencies, and you may be able to hear that the bass frequency has changed just a little. So that's normal. That's basically bass boost. So yeah, it is working as depicted. Might just drop the level of that off a bit so it's not driving it so hot. Yeah, so this little super ear project works great. So I suppose we can put the battery in the unit and put the top cover on just to house the entire thing. If you really wanted to, you could probably stick some shielding or something on the inside of it to get rid of that buzz, but as I say, you don't really hear it through headphones as much as you do through the lead that's connected to it going to the computer. So, well, as it works, I don't need to have it apart anymore, so I can put it back to put the screws in it, and we can listen to every sound of me turning a screw and picking things up off the desk. So there we have it there. There's the Super Ear Kit. It only took about 2 hours, as it said. That was pretty much accurate. And oh yeah, I love the smell of electronics in the morning. Yeah, anyway. That's enough of that, you dirty bastard. So this is a $30-odd kit. Very fun. I don't know if you can still get it readily, but I'll have a look before publishing this video. But if you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description below. And as always, this is the Astro 30 saying, see ya, happy eavesdropping.